Now we are going to do problem 2 of section 1.
In a bag of 80 chocolates, 30 of almond, 27 of milk, 23 of cookies and cream. What is the probability of both chocolates you pick are cookies and cream? You add 23 over 80 times 22 over 79, and the answer is 0.080. Question B. The probability of at least one is cookies and cream. You get the sum of cookies and cream, that is 23 over 80. And the answer is 0.28. Problem C. The random variable x number of chocolates, cookies and cream results on a binomial distribution. No, this is not a binomial distribution because it does not satisfy the conditions of being two mutually exclusive possible outcomes. Binomial distribution, we write the experiment so that it will be one. In a bag of 80 chocolates, 32 of them have almond and the rest don't. Find the probability that one has almond.
I'll explain problem number 8 from section 2. The problem we're given, they give us a probability distribution table, and they're asking us to find the value of k and update the values of the table, to find the expected value, and to find the variance. So first of all, we need to find the value of k. We know that in a probability distribution table, the sum of all of these will be equal to 1. So we will say 2k, this will turn it into a decimal, so this will be equal to 0.14, and this will be equal to 0.11. We need to leave the k alone to know what this stands for. So we will have 5k plus 0.14 plus 0.11, which is equal to 0.25 equals 1. We'll take this to the other side as a negative, and we'll say 1 minus 0.25, which will be equal to 0.75, and then we'll pass the 5 dividing, so it would be 0.75 divided by 5. So finally, our k will be equal to 0.15. That's our first answer. We've just found the value of k. Then we need to update the values on the table. Therefore, we already know that for 1 it's 0.14, for 3 it's 0.11, and now we need to substitute the k with this decimal. So we'll say 2 times 0.15, which is equal to 0.3, and then we will say 3 times 0.15, which is equal to 0.45. Just to make sure that this answer is correct, we will add all of these to make sure it gives us 1. 0.3 plus 0.14 plus 0.11 plus 0.45 equals 1. Therefore, answer is correct. Then, the second step is to find the expected value. We know that the formula to find the expected value is the addition of the probability of x times x. So we already have our x values, we have the probability of the x values. We need to multiply these by these and then add it. So we'll say negative 1 times 0.3 gives us negative 0.3. 0.14 times 1, 0.14. 0.11 times 3, it's 0.33. And 0.45 times 5 equals 2.25. So to find the expected value, as mentioned before, we will add px, it's the addition of the probability of x times x. We already did the multiplication, we will add all of these numbers. Negative 0.3 plus 0.14 plus 0.33 plus 2.25. That gives us 2.42. So that's our expected value. Then they're asking us to find the variance. We know that the formula to find the variance is the sum of x minus your u, the u is the same as the expected value, squared times px times the probability of x. We already have this value here, which is the probability of x. We just need to find the x minus the expected value squared. This is negative 3.42, negative 1.42, 0.58, and 2.58. To do this, we just subtracted the x value minus this 2.42. Afterwards, we would square all of these numbers. And finally, we will multiply these by the probability of x, which we have over here. So just to set the first example, it'd be 11.69 times your px, 0.3, which will give you 3.5. And we will do that for all of the numbers. 2.01 times 0.14, 0.33 times 0.11, and 6.65 times 0.45. And to find the variance, we will add all of this. 3.5 plus 0.28 plus 0.03 plus 2.99. And our answer is 6.8. We just learned how to find a value in a probability distribution table, how to substitute the values in the table, how to find the expected value, and how to find the variance.